Okay, this is the second part of the Chapter 9 notes for Sections 1 and 2. We've already gone through most of the notes. Just wanted to hit on a few more things. We've talked about the entire four-step process for the test. We were on words of caution, words never to use, and we talked about statistical significance is something that you will come across in a multiple choice situation. And it basically just means that the p-value is as small or smaller than your alpha. Then you have a sample result that is considered to be statistically significant. We've talked about how to write your conclusion based on the p-value. If they don't give you an alpha level to compare it to in the problem, then you should use 0.05. This is just like a standard reference. All right, so remember that when we do the hypothesis test, the significance test, we're never going to be able to prove that the null hypothesis is actually true. We're only looking for evidence to say that the null is either wrong, in which case we reject, or we don't have enough evidence to say that it's wrong, which is fail to reject. And that's very important that when you write your conclusion, you don't write it in terms that you have proof that the null is true, because it's not. We never will be able to prove that. Confidence intervals and two-sided tests. When you have a two-sided test and you compare your p-value to it, if you're only looking at one end of the curve, your alpha level is split in half as to what you're comparing it to. In other words, if I have a null hypothesis that p equals, we'll just use the Skittles example, 0.20. For an alternative of p not equal to 0.20, I'm either going to end up with a sample result that causes me to shade below the mean of 0.20 or above the mean of 0.20. So your sample is only going to point you into one direction, but let's just say that the p hat ends up being 0.04. So let's say p hat equaled 0.04 somehow. Then we're looking at this value down here, which is a z-score, because we've used this in the past. Our z-score was negative 4.03. We also have to consider that if the proportion was higher than 0.20, and for the z-score, that would have been positive 4.03. Because when we originally started, we didn't have a clear direction in mind. So we have to include both possibilities in our answer, which causes your p-value to get multiplied by 2. So I still have in my calculator the one prop z-test from the Skittles example. So if I hit stat, go over to test, and I do one prop z-test again, and this time if I choose, well, let's just review. When it was less than, our p-value was 0.00003. So for before, when I had my null, was still that p equaled 0.20, and that the alternative was that p was less than 0.20, and I got a p hat of 0.04, and my z-score for that p hat was negative 4.03. My p-value, that area shaded below 0.04, was 0.00003. And that's basically extreme, as we mentioned before. This z-score is negative 0.04. This little tiny area right here is that p-value. If I switch the test to a two-sided test by highlighting the not equal to and calculate, keeping all the same information, now my p-value is 0.0006. So the z-score is still negative 4.03, but now since we're going in both directions, the p-value is 0.00006, which is 2 times what it was before, just because we selected the not equal to. We're still comparing it to the same alpha level of 0.05. In both cases, the probability of this occurring is basically 0, so yes, you would reject the null in both cases. But it's just good to understand the difference between your two-sided test and your one-sided test. You're less likely to reject your null if you choose the two-sided, the not equal to, because you are doubling your p-value in the end. Now in this situation, of course, you would still reject it, but if our p-hat was closer to the proportion of 0.20, then it may change or alter our decision. So that is something that they will come across in a multiple choice situation. I'm sure we'll see an example here in a little bit. If you look at this blank side here, in class I provided the answer key to this. It's just an outline for you to follow a procedure pretty much as far as what to do for the confidence interval and the hypothesis test. If it's a confidence interval, they usually will tell you to create. So the problem will say, create a confidence interval. Or with 95% confidence, what would the interval be? If the problem wants you really to do a hypothesis test, the problem will say, is there evidence? Do you agree? This is when you're looking for evidence. If the parameter is wrong. The assumptions and conditions vary slightly. If we look at the answer key for the 8A group, I didn't get a chance to mention this morning because of the earliness of the ring assembly. There is a typo in it, and I know there were a couple of people still confused when we were doing the Skittles activity. For the assumptions and conditions, for the test, you're comparing your sample size to the proportion of the population. And when you come down to the standard deviation of the statistic, here's where the mistake was. I had originally written it as p-hat times 1 minus p-hat, which is your standard error, which is not true. For the population, when you're doing your hypothesis test, you need to use the parameter given to you, like the 0.20 for the Skittles, and not what your actual p-hat is. This only matters if you're one that likes to use the formula, unless they ask you for the standard deviation and we're doing a test statistic. So again, this is a general format for you to follow along with. Okay, I'm going to cut this off right now. I know it's only 8 minutes, but I'll make a new video of the possible bookwork problems.